All right, so 2.5, we get into correlation and best fitting lines. We kind of put together the whole reason why we have to write equations for lines in this section. So a scatter plot is something you've probably heard of before. It's a graph used to determine whether there is a relationship between paired data. So the graphs can be positive, they could be negative, or they could have no correlation at all. So when these points kind of form a pattern of a line going up from left to right, we say it's a positive correlation. When they come down from left to right, like the middle graph does, this is a negative correlation. And then like the last graph, you see how there's really no pattern. These don't kind of form a line at all. So this is no correlation. So it can be positive, can be negative. Sometimes there's no correlation at all. Okay, so how we use these. The best fitting lines. It says to approximate the best fitting line given the data or given the scatter plot. So what we're going to do is pick 2 points to draw our line through. I'm going to pick this point and this point because when I connect those dots the best I can, do you see how there are 3 points above? There's the 3 blue points that are above that line and the 3 green points that are below that line. So that's kind of what I'm going to pick to the best approximate this scatter plot. You can obviously pick 2 different ones that might also draw a pretty good line going through there. These answers may vary, and they still could. There's more than one right answer. So the first red point I picked, the ordered pair is -3, 2. All right, the x value is -3, the y value is +2. The second point I picked over here is 1, 0. The x value is 1, the y value is 0. So those are the 2 points we're going to use. So just like on your quiz and just like in the last sections, we've been writing equations for the line. So to write an equation for a line, we first have to find the slope. We have to find m or find the slope. So that'll be you take your y values and you subtract them, and then take your x values and subtract them. So y2 minus y1 over x2 minus x1. So it would be 2 minus 0 over -3 minus 1. We would get 2 over -4, which is -1/2. That will be our slope. Okay, another way to get the slope would be if you start at one point. From here we go down 2, to the right 1, 2, 3, 4. So -2 over +4 would be -1/2. So there's more than one way to get your slope when you have your 2 points. So we have m, and I'm going to pick a point. I'm going to use one of the points I have. I'm going to pick the point 1, 0. So I'm going to use the point 1, 0. So now we have m, we have an x, and we have a y. So we have m, we have x1, we have y1. So now I'm going to use the equation y minus y1 equals m times x minus x1. Okay, and this is our point slope equation. We're going to use that to write an equation for this line. So we plug in our y value, which is 0. So y minus 0 equals, our slope is -1/2 times x minus 1. Okay, we distribute -1/2 x, and then -1/2 times -1 is +1/2. So we end up with y equals -1/2 x plus 1. That would be the equation for the best fitting line. So if we're given 2 points, We can use those 2 points to find the slope. After you find the slope, you use point-slope formula, which is right here, point-slope formula, and we plug in a point and a slope, and we find our equation. Okay, we'll try that again. For example, one down here. So if we use the information in the table, draw a scatter plot of the data, then approximate the best fitting line for the data. So first we're going to graph these points. So -4, 6. -4, 6 would be the left 4 and up 6. Then -3, 4 to the left 3 and up 1, 2, 3, 4. -2 and then 4.5. So to the left 2 and then up 1, 2, 3, 4 and a half will be right about here. -1.5 and then +3. -1/2, +2. 0, +3. 1, +1.5. 2, 2. 2.5, 0.5 is going to be kind of in the middle here. 2.5, and then the y value is 1/2. And then 3, 0. Okay, so your scatter plot looks like this. And if you can't print notes, just sketch your graph the best you can. Try your best, and you can label your points as we go here. I'll show you what I mean by that. So then you're going to try to draw a straight line through 2 points. I'm going to pick this point right here, 3, 0, and I'm going to pick this point over here. And the reason why is when I draw my line through these, that red line kind of goes right through the middle of everything. Okay, and you could obviously pick a different point and still get a line that is pretty much through the middle. But I just picked those 2 points because I think they'll work well for me. So the points I picked were, this one is -4, +6. And the other point I picked over here is 3, 0. So now we have our 2 points. We got to find our slope. So to find the slope, you can either count the slope or use your formula. I'm going to use the formula. Actually, I'll do both. So to find the slope, it would be 6 minus 0, because you take the y minus the other y, and then you do your x's and subtract them. So -4 minus 3. Our slope is 6 over -7. So it's going to be a fraction, which is fine. If we counted the slope, we would do this. You'd start at your point, and you'd go down 1, 2, 3, 4, 5, 6, so -6. And then to the right, 1, 2, 3, 4, 5, 6, 7. So down 6, and then to the right, 7 would be -6 over 7. So notice the slopes will be the same, either way you do it. -6 over 7 or 6 over -7. We still get the same slope. Then we pick a point. Pick one of the points to use. So we can either use -4, 6, or 3, 0. I'm going to use 3, 0, because those numbers are a little bit easier to use for me. A little easier than -4, 6. So we have x1, y1, and m. So use your equation again. The equation is y minus y1 equals m times x minus x1. And now we plug in our numbers. So it's y minus 0 equals -6 sevenths times x minus 3. Okay, so we distribute. We get -6 sevenths x, and then -6 over 7 times -3 is going to be +18 over 7. So y equals -6 sevenths x plus 18 over 7. And that's our line of best fit. And this last problem just shows how we can use this to predict something. We can use this to predict population, the number of animals in a certain area. It can be used for many, many, many things. We can predict the price of something in the future. This kind of stuff is used in a lot of different areas. So the example we have is the table shows the number in thousands of black and white televisions sold in the United States from 1955 to 1995. So if you're not aware of it, before we had our flat screens and our big smart TVs, there were black and white TVs. Okay, so we're going to draw a scatter plot, and we're going to try to do a line of best fit for this example. So along the X, we're going to put the year. And for the Y, we're going to put TVs. So black and white TVs. So we have to go from 55 to 95. So 1955, and then 60, 65, 70, 75, 80, 85, 90, and 95. Okay. And then for the TVs, we have to go up to about 8,000. The biggest number is about 8,000. So if we go up by 1,000s, so 1,000, 2,000, 3,000, and so on. So your biggest number is going to be 8,000. And again, you can just sketch this graph. I know many of you can't print. So we put the points on here. The first point is 1955, and then 7,738 is going to be right about here. And then 1960, and then 5,700. So 65,700. 65, it goes up to 8,700. So that one goes up above the 8,000. It's going to be somewhere up here. In 1970, it's 4,700. 75 is just below 5,000. 80 is 6,684. 85 is 3,600. 90 is 1,400. And 95 is all the way down to 480. So you can clearly see that the number of TVs comes down as the years go on. Okay. And if you were drawing a line of best fit, your line of best fit would go through here. I'm going to pick those 2 points. So your line of best fit would look like that. Okay, now if we wanted to, we could write an equation like we did in the past, like the last 2 problems, and we could make predictions how many black and white TVs will be sold in 1998 or in 2000. I think that they pretty much were gone. When they hit around 2000, there were no more black and white TVs because we were into the new age. So this is how it can be used. We're going to stop right here, and we'll go over some of the stuff in class.